The Moon has been struck by billions of rocks over its 4 billion-year history. Every single hour, meteoroids slam into the surface, excavating soil and throwing debris into the vacuum of space. But almost all of these natural impacts are anonymous. When astronomers look at the overlapping scars covering the lunar surface, they have to guess at the specifics. Scientists cannot verify the exact hour a natural meteorite struck, its velocity, or the exact mineral composition of the rock itself. That all changed on August 5, 2026. A brand new crater formed near Einstein crater on the lunar far side, and this one arrived with a complete, highly documented biography. We know exactly what made the hole, a discarded upper stage of a SpaceX Falcon 9 rocket. We know it weighed approximately 4 tons, and we know it hit the regolith traveling at Mach 7. Because the initial mass and velocity were tracked from launch, researchers can treat this uncontrolled collision as a known case study for impact physics. The hardware actually originated from a January 2025 launch. The Falcon 9 successfully delivered the Blue Ghost lunar lander on its way to the Moon, but the upper stage, a massive hollow cylinder, was left behind in orbit. For 18 months, the discarded rocket stage drifted through space entirely without propulsion. This animation tracks the Earth-Moon system, showing how the rocket's orbit decayed over that year and a half. Without any mechanical thrust, gravitational pulls from both the Earth and the Moon, along with solar radiation pressure, gradually altered its path. By the time it collided with the Moon, it wasn't due to a navigation error. The intersection of that drifting orbit and the lunar surface had simply become a mathematical inevitability. A typical natural asteroid strikes the Moon traveling at an average of 15.9 kilometers per second. The Falcon 9, fast by earthly standards, hit the surface at roughly 2.5 kilometers per second. This comparison illustrates the physical difference between a dense solid sphere and a hollow cylindrical structure. These physics dictate how the impact site eventually forms. Focusing on the cylinder side of the animation, you can see how it buckles and fragments under its own momentum. Instead of vaporizing on impact like a hypervelocity meteor, the metal structure crushes, gouging out the top layer of lunar soil. Knowing the exact time and location of the impact triggered a scramble among astronomers. A telescope array in Chile, operated by the European Southern Observatory, managed to capture the resulting debris plume illuminated against the dark sky. This chart breaks down the spectral data extracted from that dust plume. By splitting the light into distinct emission signatures, scientists identified sodium originating from the ancient lunar soil, alongside clear traces of lithium belonging to the rocket stage itself. Having that known chemical baseline allowed researchers to directly observe exactly how native lunar dust interacts with artificial spacecraft materials in real time. NASA and several commercial space companies are currently developing plans for sustained human habitats on the lunar surface. That introduces a serious problem regarding ejecta. Because the Moon lacks an atmosphere and has very low gravity, any displaced rock and dust from a landing or a crash turns into high-speed shrapnel that can travel for hundreds of kilometers. This technical image from the LCROSS mission illustrates the spread of artificial ejecta. Scientists rely on these documented events to map how far and how fast displaced material travels across the vacuum. Understanding the specific spray pattern and the abrasive, sticky nature of lunar dust is critical for designing habitats and spacesuits that will keep future astronauts alive. But as plans for exploration accelerate, the region between Earth and the Moon, known as cislunar space, is becoming crowded. Right now, there are no comprehensive international laws dictating how to safely dispose of heavy orbital machinery once a mission ends. This satellite imagery from the Lunar Reconnaissance Orbiter shows the fresh crater left by the Luna 25 probe. Probes like this are increasingly tasked with documenting these physical scars to monitor the damage caused by uncontrolled artificial collisions. The August 2026 Falcon 9 impact gave scientists a rare set of data to understand the mechanics of lunar impacts. But a massive, uncontrolled rocket stage hitting the Moon is also a clear signal that the space industry needs a standardized plan for taking out its trash.